Yes, we are talking about type of clustering. So in the previous class, we already discussed about the clustering, what is actually clustering, and we already discussed about the one of the method, k-means clustering method. Okay, so we already taken the example of basket of vegetables. How can we separate uh, various types of fruit or vegetable? Okay, whenever you close your eyes, and how can we separate the potato, onion, and tomato? So we already discussed as a unsupervised learning example in the previous lecture, and we already taken one of the example of target marketing. Okay, so how can we receive the call from the bank regarding the credit card or home loan, personal loan, etc. So this is the possible just because of clustering. Okay, and we already taken one of the example of Netflix. Okay, okay. How can we recommend to you that platform for that particular movie, particular any any show like comedy night with couple like this. Whenever you watch this show on the Netflix, so similarity of these show Netflix find out some of other shows related which is related with which is having some similarities with Comedy Night with Couple, and it will be recommended to you. So how can we how can it is how is it possible? Just just it is possible just because of clustering clustering in machine learning. Okay, so there is some type we are discussing here, type of clustering. So first one is distribution based method. So in this clustering model, in which we will fit the data on probability. In this type of method, this is the clustering model, and in this type of method, we will fit the data on probability, that how it may belong to the same distribution. Okay, so basically we can say data may be belong just because of same distribution with the help of probability. Got it? So we can say here in one single line what is actually distribution based method. In this method, we will fit the data on probability. We will fit the data on probability where we store where the maximum probability to fit that particular data and fit that another particular data and fit another particular data. Got it? Like this. You can see in this picture. So these are the data points. These are the data points having some similarities and having some probability to belong this distribution. This one. Okay. Another data point having some similarities, having some probability to fit that particular distribution. Okay. And another data points are like these blue points, data points. You can see here there is some another distribution plane. So you can say there these are the data points which having some same distribution, which having some same probabilities, similarities. So these all blue points having same fit on saving fit on same distribution. Okay, so you can see there is three distributions are there: first one, second one, and third one. Got it? So this is the basic distribution based model concept, and the grouping done by normal or Gaussian distribution. We can use, we already heard this thing, normal and Gaussian distribution. Uh, if you completed your 12th with mathematics background, so we learned this Gaussian and normal distribution at 12th standard. Okay. So Gaussian distribution is more prominent where we have a fixed number of distributions and all upcoming data is fitted into it such that the distribution on beta may get maximized. So for the grouping purpose in the distribution based method we have to use normal or Gaussian distribution method. So normal distribution, what is this? Normal Gaussian distribution is more prominent where we have a fixed number of distribution, where we have fixed number of distribution as well as all upcoming data is fitted into it. We already said this thing. Okay, so it is fixed by the distribution based method. How it may belong to the same distribution. Okay, so in that distribution of data may be get maximized and that particular distribution. Okay, so this model works well on synthetic data and diversely sized clusters. Distribution based method works well on the synthesized data and diversely sized clusters, but this model may have problems if the constraints are not used to limit the model complexity. Whenever we deal with some problem in that particular, whenever you use this model, so we faced with some problem whenever the constraints are not used to limit the model's complexity. Okay. Furthermore, distribution-based clustering produces clusters that assume concisely defined mathematical model underlying the data, a rather strong assumption for same data distributions. Okay. So finally, we can say the distribution-based method finally we use for the cluster purpose. With the help of this method, we can make cluster. In that, we assume concisely definite mathematical models underlying the data and rather strong assumption for the same data distribution. One of the example to understand the uh, distribution-based model, first one, exception maximization algorithms. Exception, expectation and maximization algorithm, which uses multivariate normal distribution, is one of the popular example of this algorithm. Second one is centroid based method. Centroid based method. This is basically one of the iterative clustering methods in which the cluster are formed by clonage of data points to the centroid of the cluster. We already discussed one of the example of centroid based method is k-means. We already taken one of the numerical example how k-means work in the previous lecture, in the previous slide. Okay, so this is basically based on the center of the cluster, centroid based method you can say. Okay, so in that method the clusters are formed by cloneness of the data point. Clusters are formed by cloneness of the data point to the centroid of the cluster. Okay, so firstly we have to assume centroid of the cluster. Assume centroid of the cluster. Then we have to calculate the each data point distance from that particular centroid of the cluster. Okay, then we have to find out the reachability of the each data point to the different three clusters. We already discussed in last lecture. Okay, so in a better way we can understand this method with the help of k-means method. Okay, here the cluster center. It means centroid is formed such that the distance of the data points is minimum with the center. Okay, this problem is basically one of the NP hard problem, and the solutions are commonly approximate over a number of trials. Approximated over a number of trials. For example, k-means algorithm is one of the popular example to understand this algorithm, this method. We already said. Okay. The biggest problem with this algorithm is that we need to specify k in advance. But according to the requirement of the user, you can specify the value of k. Okay. It also has problems in clustering density based distribution. So whenever you deal with some method, whenever you deal with some new method or existing method, so you can face some problem to learning purpose. Okay. Whenever you frequently deal with these algorithms or new algorithms, so you can going this easy way. Okay. So this is the diagram to you can understand the centroid method. Okay, so you can say there are two cluster. First one is and second one is. Okay, this is the cluster center. This is the cluster center, and this is also another cluster center. And now we calculate this cluster center to each data points distance. You can see here. Okay, similarly in this. Okay, according to the distance, we can identify the reachability of the cluster. Okay, got it? For example, all these points having minimum distance from this cluster center. Okay, so we can say all these points making a single cluster. All these points having the also minimum distance from this cluster center, so you can make another cluster. Okay, so you can see this diagram. For example, this is the one of the cluster, and this is the cluster center. And how can we this is the distance from each data points of from this cluster center. Similarly for this. So this is the centroid. This is the center of the cluster. This is also center of the cluster. So we can say this method is based on the centroid. Okay. Next one is density. You cannot say every cluster having the spherical form. You cannot say. Okay. So this is not compulsory whenever you deal with the clustering. So clustering will be in a spherical form, like circle. You cannot say. Okay. So density model specify this thing. In this clustering model, there will be the searching of data space for areas of very density of data points in the data space. Okay, there will be searching of data space, searching of the data space for area of very density of the data point in the data space. You can see in this picture, these are the data points where then density of these data points high, and another data points are, you can see here, blue data points having maximum density for that particular area of that data space in the data space. So there are two clusters. First one is spherical form and next one is in this form. Okay, so you can say there is no any compulsion whenever you deal with the clustering algorithm. So cluster will be in a spherical form. You cannot say. Whenever you deal with the density model, so you can um, vary the cluster size, cluster shape also. Okay, it depends on the density, where density reach high. So in that case, you can say in this model there will be searching whenever you deal with density model. Searching of the data space for area of varied density of data point in the data space. Okay, it isolates various density regions based on the different densities present in the data space. We already discussed this thing. So we can say there are the data points having maximum densities present in the data space for that particular data points. Another data space are there for, you can see. Blue data points are there having the maximum density and similar density all these data points. Okay. So examples are DBSCAN and optics. Both of the method follow the density concept. Connectivity based method. The core idea of the connectivity based model is similar to centroid based model. The core idea behind of the connectivity based model is similar to the centroid based model, which is basically defining clusters on the basis of cloneness of the data point. In this method, we have to define the cluster on the basis of cloneness of the data points. Cloneness, that means, for example, there are some data points and we can make some clone of that particular data points which are having same all similar symmetries. Okay, here we work on the notion that the data points which are closer have similar behavior as compared to data points that are further. It is not a single partitioning of the data set. Instead, it provides an extensive hierarchy of the cluster that merge with each other at certain distance. Here, the choice of distance function is subjective. The models are very easy to interpret, but it lacks scalability. You can see here there is the some cluster. First one is, second one is, and third one is. This cluster make with the help of cloneness of the data points, and you can say it is not a single partitioning of the data set. Whenever you deal with the connectivity based method, okay, instead it provides an extensive hierarchy of the cluster that merge with each other at certain distance. You can see all of these data points have make a single cluster, okay, because they these data points having certain distance, there's no any you cannot see here one of this data points having similarities with this cluster, and you can include this point also, you cannot, okay, because distance matter is here. Okay, so you can say the choice of distance function is subjective. Okay, and this model are very easy to interpret, but it lacks scalability. Okay, so example is hierarchical algorithm is and its variants are the most popular example to understand the connectivity, and we will discuss in next slide also. Okay, hierarchical clustering methods. Hierarchical clustering method works via grouping data into a tree of cluster. Hierarchical is grouping of data in a tree manner, you can say. Okay, so we can say that here hierarchical clustering method works via grouping data into a tree of cluster. Hierarchical clustering begin by treating every data point as a separate cluster. Every data point we have like as a separate cluster. Then it repeatedly execute the subsequent step. First one is identifying the two clusters which can be closest together. Identifying the two clusters which can be closest together. Second one is merge the two maximum comparable cluster. We need to continue these steps until the all cluster merge together. So remember all these 2 points. First one is identifying the two cluster which can be closest together, and second one is merge the two maximum comparable clusters. We need to continue these steps until all the clusters are merged together. Okay. So in hierarchical clustering, the aim is to produce a hierarchical series of nested cluster. Hierarchical series of nested cluster. A diagram called as dendrogram. What is this dendrogram? The dendrogram is a tree-like diagram that statistics the sequence of merges or splits. It's a representation of sequence of merges and sequence of splitted. Okay, so that's called the dendrogram. Okay, and dendrogram graphically represent this hierarchy, and it is an inverted tree that describes the order in which factors are merged. Okay, so it will be bottom up view. Whenever cluster are broken up, you can say that will be top down view. There are two methods, bottom up view and top down view. With the help of dendrogram, you can understand both of these things, bottom up view and top down view. In the bottom up, uh, we work with the merging, and in the top down view, we deal with the broken up of the cluster. Okay, so this is the hierarchical structure of the clustering. Firstly, we already said every cluster consider behave like as a single cluster. You can see here A, B, C, D, E, F, G, H, I, J, K, L, M, N. All of these points behave like as a single cluster. Okay, so now we consider as a hierarchical form. How can we create this hierarchy? We already said in the two points are here. Identifying the two clusters which can be closest together. Remember first thing. Okay, firstly we identify two clusters which can be closest together. Okay, so you can see here there are some uh, clusters C and D, both are closest together, and A and B both are closest together. So you can combine here A and B and C and D. So now C and D behave like as a single cluster, and A and B behave like as a single cluster. Now both of the cluster like this one and this one having the closest distance from E. So you can make a single cluster, three of them. Okay. So now we conclude with E. E is a single cluster and this one is the single cluster. Okay. And combine both of three. Okay. First time, second, and three. Got it? So this one we have like as a single cluster AB, and second cluster CD, and third cluster ABCD. Similarly, we can connect with E. So this one is a single cluster. Okay. Similarly, we will work with these data point. There are F and G having the closest distance. Okay, so we can connect with both of them. And next H. H is also now F and G we have like as a single cluster, and H is another cluster. So this cluster and this cluster having closest distance, so you can combine both of them, both of them, sorry. Now similarly we can see here J and K having closest distance. So J and K come with we have like a single cluster. Now we connect with L. So L is closest with the J and K. So this is the cluster. We have like as a single cluster. Now we can connect with I. So now I is connected with this. Now MN only two data points and connect with both of them. So MN is we have like as a single cluster, and cluster of distance you can specify with this, and directly connected with all of them like this. Okay, so this is the way to making a hierarchical clustering concept. Okay, so you can see another part of this clustering. Okay, so how can we connect all these data points like this? A, B. Firstly, we compare with the distance. So AB having the minimum distance, so AB connect with AB. Okay, so AB, next is CD having the minimum distance, so CD is connected with this. Now, if you want to connect with E, so you can connect with this and E. So ABE, and now we connect with this to this. That means ABE and CD. So this will be ABCD. Okay. So now hierarchical clustering method types. So as we discussed, hierarchical clustering having two types, agglomerative and second one is divisive. So firstly we discuss about the agglomerative. Okay. Initially, initially consider every data point as individual cluster as we said, and at every step merge the nearest pair of the cluster as we see in the previous diagram. Okay. So it is called the bottom up method. Firstly, we consider the all data points as an individual cluster. Then, and the next step, we merge nearest pair of the cluster. It is called the bottom-up method. Okay. At first, every data set is considered an individual entity or cluster. At every iteration, cluster merge with different cluster until one cluster is formed. Every iteration, the cluster merge with different clusters until one cluster is formed. Got this point? Okay. So the algorithm for agglomerative hierarchical clustering is calculate the similarity of one cluster with all the other clusters. Then we can say calculate proximity matrix. Proximity matrix. Okay. So firstly we calculate the similarity of one cluster with all other cluster. Next, consider every data point as a individual cluster. Okay. Next, merge the clusters which are highly similar or close to each other. Highly similar or close to each other. Then, recalculate the proximity matrix for each cluster. Then repeat step number 3 and 4 until only a single cluster remains. Okay, so these are the basic steps whenever you deal with the agglomerative hierarchical clustering. Okay, these are very simple steps to follow whenever we deal with the agglomerative hierarchical clustering. Let's see the graphical representation of this algorithm using dendrogram. Note, this is just a demonstration of how the actual algorithm works, no calculation. This is just a demonstration of how the actual algorithm works, no calculation. Has been performed below all of the proximity among the clusters is assumed. So remember this thing, okay? So step number 1, okay, there are 6 data points A, B, C, D, E, F. Step number 1, consider each alphabet as a single cluster. You can see here A, B, C, D, E, and F. All behave like as a single cluster. So we can consider as a single cluster all of these data points. Okay. and calculate the distance of one cluster from all other clusters. Just like this, we can calculate the distance from A to B, A to C, B to C, C to D, like this, all of the cluster, okay, from each cluster. Okay, so we can see here B and C having minimum distance to each other, and D and E having minimum distance to each other. Got it? So in the second step, comparable clusters are merged together to form a single cluster. Like this, B and C having minimum distance, so B and C having minimum distance, so B and C consider as a single cluster because we merge together B and C. Similarly, D and E merge together and consider as a single cluster. Okay, you can say cluster B and cluster C are very similar to each other. Therefore, we merge them in second step. Similarly to cluster D and E having maximum similarities, so we can consider as a single cluster. Okay, at last we get the cluster. We get the cluster now in second step A, B, C, D, E, and F. So this is the cluster set in we get in step number 2. Now, step number 3, we recalculate the proximity according to the algorithm and merge the two nearest cluster. Again, we calculate the two nearest cluster distance. Okay, so now we found here DE, that means this cluster, and F having the minimum distance. You can say this cluster and this cluster having the maximum similarities we find here. So we can merge both of them at the step number 3. So now we have new cluster set is A, B, C, D, E, F. Okay, so this is the new cluster set as step number 3. Now again, step number 4, repeating the same process. Repeating the same process, the cluster DEF and BC, DEF and BC are comparable and merged together to form a new cluster. Like this, we can compare and found some minimum distance and more similarity. So we merge both of them, BC, DEF. So now we have like this. At step number 6, we found a new we get new cluster set which is having A cluster and B, C, D, E, F. Okay, now again repeating the same process. At last we get only two clusters are there, A and B, C, D, E, F. Okay, so two remaining clusters are merged together to form a single cluster. Like this, we get A, B, C, D, E, F at step number 5. This is the process we have to follow in the agglomerative clustering method. Whenever you follow this method, you will get a single cluster. Okay, I hope you all understand this method. Second one is divisive hierarchical clustering method. We can say that divisive hierarchical clustering is precisely the opposite of agglomerative clustering technique. You can see this picture. This is the reverse form of the agglomerative. Got it? So in divisive hierarchical clustering, we take into account of all of the data points as a single cluster like this A, B, C, D, E, F. Okay, we separate the data points from the cluster which are not comparable. In that case, suppose we have a single cluster A, B, C, D, E, F, and firstly we try to separate all data points from the cluster which are not comparable. So now we get here A and B, C, D, E, F are not comparable. So, we separate both of them. So A is there and B, C, D, E, F. Okay. Again, in this step number two, we get A having single data point, but in the second cluster we have B, C, D, E, F. Okay. So now we again compare and we found the most of the dissimilar cluster, and we try to find out the cluster which cannot comparable, which are not comparable. So we find out here we got uh, B, C, and D, E, F. Okay, at the step number three we have A, B, C, and D, E, F. Again, same process we have to follow here, and we try to find out here which are the cluster are not comparable like this. Okay, we have A, B, C, and D, F. So in this case, we try to find out the cluster which are not comparable. So now we get here from the DEF, DE, and F. At the step number four, we get here A, B, C, D, E, and F. Again, we follow the same process and try to find out the cluster which are not comparable in that cluster and that cluster. Okay, so again we uh, this process we have to follow whenever we received an cluster, single cluster. Okay, so like this, whenever you separate, whenever you compare B and C, we get B and C. Whenever you compare D and E, we get D and E. At the step number five, you will get all of these and all of these the data point A, B, C, D, E, F. All of these cluster consider as a all of these data point considered as a single cluster. So this is the divisive process. This is the divisive hierarchical clustering. Okay, this is the you can say just opposite method of the algorithmic clustering, hierarchical clustering method. Okay, so now why hierarchical clustering? As we already have other clustering algorithms such as k-means clustering, then why we need hierarchical clustering? So there is some reason. So as we have seen in k-means clustering, as we discussed in previous lecture, that there are some challenges with this algorithm, which are a predetermined number of clusters are there, k value, predetermined number of cluster. Whenever user want to three cluster from the data set, whenever you want to user want to five cluster, so you can just put it here k value, k is equals to 5, k is equals to 3, and it always tries to create the cluster of the same size. So this is the predetermined number of clusters are there. Okay, to solve these two challenges, we can opt for the hierarchical clustering algorithm, because in this algorithm, we don't need to have knowledge about the predetermined number of the cluster. According to the similarities, we find out the cluster, number of cluster, not predefined number of cluster. Okay, for example, you have a data set and we want to perform the clustering on that particular data set, and you already defined the value of k. That means three cluster if you want. So now in that case, you will find only three cluster from that data set. Got it? Yes or no? And if you want to put the value of k, that means you want to five cluster from that particular data. So you will get the five cluster sets are there. Okay, with the help of k-means. But in that case, in the hierarchical clustering method, we cannot define the value of k. According to the hierarchical clustering, you will get the accurate result of the cluster, whatever number are there. Okay, so that's it. Now Machine learning with anomaly detection. Okay, anomaly detection is a process of finding those rare items, data points, events, or observations that make suspicion by being different from the rest data point or observations. Got it? It's a process of finding those rare items, data points, events, observations that make suspicion by being different from the rest data point or observations. That is the main concept behind the anomaly detections. You can say anomaly detection is also known as the outlier detection. So, outlier detection. So, anomaly detection is also known as outlier detection. So, how can we explain the outlier means what? So, for example, there are five students and uh, there are five students and we these students appear the examination and got some result and got some result and in that result they get first of the student get the 9 grade and second 8 uh, and third one got the 9 and fourth one got the 7 and fifth one got the 2 grade only. Okay, so you can see here first four having the approximate similar value, similar grade, but at last value seems to be an outlier because it's got that student got only 2 grade. Okay, so last grade seems to be an outlier because if fall it fall below the main pattern of the other grades. Got it? So that is the outlier example. You can understand. Similar thing happening here. Anomaly detection. You can say anomaly detection is actually process of finding those rare items, rare data points, events, and observation. Okay, that makes suspicious by being different from the rest data points or observation. Like in this example, we want to explain here. Like there are five students, and all of five students appear the examination on the same day. But after the declaration of the result, starting four results, first student one, student two, student three, student four got around approximate same grade, but student number five got 2 grades. So that is rare grade. Okay, so I think you all understand this example. Okay, generally anomalous data is related to some kind of problems such as bank fraud, medical problems, malfunctioning equipment, etc. Finding an anomaly is the ability to define what is normal. Finding an anomaly is the ability to define what is normal. For example, uh, in this image, okay, the yellow vehicle is an anomaly among all red vehicles. So you can see here there is so many vehicles having same color and having same vehicle color also. Almost all four wheeler. Okay, but only this car having only yellow color. So that is different. Okay, so this is the another example to understand the anomaly detection and outlier detection. Sorry. Okay, so you can see here and you can observe here all of the vehicle having same color. That means you can say all of the vehicles are normal, but except this. Okay, so you can try to understand. I think you understand all of the example to understand the anomaly detection. First one is student's result, and second one is anomaly car vehicle. Okay, now type of anomaly detection. So first one is anomaly, point anomaly. Anomaly. The tuple within the data set can be said as point anomaly. A tuple that is within the data set can be said as point anomaly. Only tuple. Tuple that means a row. Okay. An attribute means attribute representing by the column in the data set. Okay. So a tuple within the data set can be said as point anomaly. Okay. If it is a far away from the rest of data. Okay. For example of point anomaly is sudden transaction of a huge amount of from a credit card. In our daily routine, you can use credit card or debit card or phone pay and GPay and all. Okay, but suddenly there is some unexpected transaction, huge amount transaction from your credit card or Google Pay and all. So that is the point anomaly. Got it? Second one is contextual anomaly. Contextual anomaly is also known as conditional outliers. If a particular observation is different from other data point, particular observation is different from other data points, then it is known as conditional outliers. In such type of anomalies, an anomaly in one context may not be an anomaly in another context. In such type of anomalies, an anomaly in may context may not be an anomaly in another context. Okay, that means you can say conditional outliers, conditional anomaly. You can say contextual anomaly. Okay, next one is collective anomaly. Collective anomalies occur when a data points within a set is anomalous for the whole data set, and such values are known as collective outliers. In such anomalies, specific or individual values are not anomalous as a whole or contextually. Collective effort, collective anomalies. Okay, there is the category of anomaly detection methods. Okay, so there are three types of anomaly detections. First one is point, second one is contextual, and third one is collective. Okay, this is the category of the anomaly detection techniques. First one is supervised anomaly detection. Supervised anomaly detection need the labeled training data. As we know, always required labeled data in the supervised learning whenever you deal with the supervised learning. Got it? So, which contain both normal or anomalous data for creating a predictive model. Some of common supervised methods are neural network, support vector machine, k-nearest neighbor, Bayesian network, decision tree, and all. K-nearest neighbor is one of the popular non-parametric techniques which find the approximate distance between different points on the input vector. This is one of the best anomaly detection method because it finds the approximate distance between the different points on the input vector. Another popular model is Bayesian network, which is used for anomaly detection. When combined with a statistical scheme, this model encodes the probabilistic relationship between variable interest. Okay, supervised anomaly detection techniques have different advantages, such as the capability of encoding interdependencies between variables and of predicting events. It also provides the ability to incorporate both prior knowledge and data. Unsupervised anomaly detections. Second one is unsupervised anomaly detection. It does not require labeled training data, as you know. Unsupervised learning always required unlabeled data. Okay, so this technique are based on two assumptions, which are most of the network connections are from normal traffic and only a small amount of data is abnormal. Most of the network connections are from normal traffic and only a small amount of data is abnormal. Malicious traffic is statistically different from normal traffic. Second one is malicious traffic is statistically different from the normal traffic. On the basis of these assumptions, on the basis of these assumptions, data cluster of similar data points that occur frequently are assumed to be normal traffic, and those data groups that are infrequent are considered abnormal or malicious. Okay. Some of the common unsupervised anomaly detections algorithms are self-organizing map, SOM, K means, C means, expectation and maximization meta algorithm, EM algorithm you can say, adaptive resonance theory, ART, and one class support vector machine. Okay, SOM, or you can say self-organizing map, is a popular technique that aims to reduce the dimension of data visualization. Okay, SOM. So, need of anomaly detection technique. Anomaly detection can effectively help in catching the fraud, which may be like credit fraud detection, okay, bank fraud detection. Credit card is also considered a bank fraud detection, okay. Catching the fraud, discovering strange activity in large and complex data set. Strange activity in large and complex data set. Okay, strange, that means mishappening in your data. Okay. This can prove to be useful in areas such as banking security, natural science, medicine, and marketing, which are prone to malicious activities. Okay. With machine learning, an organization can intensify search and increase the effectiveness of its digital business initiatives. So, there are some criteria we can discuss why we use, why it is necessary. Okay, so first is anomaly detection for application performance. So application performance of any company can either generate or reduce workforce productivity and revenue. Generate or reduce workforce productivity, productivity and revenue. General or traditional approaches for monitoring the application performance allow to react to issues, but still business used to suffer and hence it affect the user. But with the help of anomaly detection using machine learning, it is easy to identify and resolve the application performance issues before they affect the business as well as user also. It is happen because of anomaly detection methods are there. Okay, so you can resolve the application performances issues. Okay, anomaly detection using machine learning algorithm can simply correlate data with corresponding application performance matrices and find out the complete knowledge of the issues. Okay, so there are different industries that also employ anomaly detection techniques for different businesses such as telco, ad tech, etc. All these companies follow the anomaly detections. Okay, anomaly detection क्या है? What is the anomaly detection? Anomaly detection using machine learning algorithm can simply correlate data with corresponding application performance matrices and find out the complete knowledge of the issues. Second one is anomaly detection for product quality. It is not enough for product manager to trust another department for taking care of required monitoring and alert. It is not enough for product manager to trust another department for taking care of required monitoring and alert. It is always required for product manager to be able to trust that product will work smoothly. It is because the product always needs changes from each version release to new features, upgradation, and generates anomalies. If you don't properly monitor these anomalies, it may cause millions of revenues lost and can also affect the brand reputation. Okay. Third one is anomaly detection for user experience. If you release a faulty version, you may experience a DDoS, distributed denial of service attack. Basically, it is used for the any corruption. Okay, risk of access lapses across customer experiences. So it is required to react to such issues before they impact user experience to reduce the chances of revenue loss. Proactively streamlining and improving proactively streamlining and improving user experiences will help improve customer satisfaction in a variety of industries, including gaming, online businesses, etc. So there are the reason why we need the anomaly detection technique. There are three uh, reason, three sectors are there. You can say anomaly detection for product quality, anomaly detection for application performance, and anomaly detection for user experience. Okay, so that's it for the first unit. We discussed in first unit all of the model, all of the supervised and unsupervised learning model. Then we have to implement. We are ready to implement all of these model. Thank you.